cellular standards, opportunities and challenges.
Anyway, good afternoon. My name is Steve Howser, and I'm glad to have the opportunity to talk today. I'm going to talk about, in fact, I'm going to talk about some of the things that Kirk has already spoken about, particularly some of the OMA standards, but I will just talk in a different way about the same things. So my name is Steve Howser, and I work for Nokia Siemens Networks. I've been working on E911 and commercial LBS positioning for about 12 years now. Anyway, I'm going to start off by speaking a few words about the last 12 years or so of positioning improvements and the standards particularly. Then I'm going to talk about the more sophisticated hybridization that's occurring with all location. Then I'm going to present some examples of some new cool positioning approaches, and then I'm going to talk about discovered supple servers and extending the OMA protocols to support some of the new indoor positioning methods. And then I'll have a few closing comments. So if we look at the, at least my career in location, is that in the very early days, in sort of early 2000s, we were just talking about cell ID-based positioning, and there weren't that many standards at the time. We were extending protocols like INAP to retrieve cell IDs during a call setup. There was, we were extracting cell ID from devices using the SIM application toolkit, and there was the very early FCC phase 1 positioning going on, which was basically cell ID based, and it was all control plane in those days. And then, largely driven by the E911 phase 2 standards, suddenly accurate positioning came to the forefront, and we were sort of forced into doing high accuracy positioning for E911. And once again, it was control plane. It was using GPS and uplink time difference of arrival to get the high accuracy positioning. And then during the 2000s, we sort of brought that same technology, which had been largely put in place for E911, we pulled it into commercial LBS. And there was various standards at the time. Originally there was some of the Qualcomm standards for user plane, the V1, V2. There was the OMA supple. There was some sort of more proprietary solutions for carriers using IDEN, which were largely user plane. But we started using mobile terminated and mobile originated positioning. So, we had applications going onto devices as well as, which were requesting their own location, as well as servers in the network requesting location. And then towards, in the last, 3 or so years, we started to see, particularly with Supple 2, more advanced standards-based positioning being deployed. And Supple 2.0, particularly from the OMA, has standardized a wide range of services. Very few of them are actually being deployed yet. Most of them are very much aligned with what was in the content of Supple 1.0. But Supple 2.0 introduced the concepts of using user plane for emergency and for periodic and triggered location within the standards. And what we're doing now is just looking at a wider, a sort of super hybrid of all positioning capabilities is what's going forward as we're going beyond the terrestrial and the satellite positioning. We're making use of all the information available, whether it's Wi-Fi and in the future much more on beacons and any other information that is available to aid location. So I think the key thing here is that even though originally, a lot of the concepts originally come in from a proprietary or vendor-specific background, over time they all tend to move towards a standards approach, and this is to allow carriers to have multiple vendors and multiple solutions, and it means that there's less risk for the operators and for business cases when there are standards. So this is a sort of diagram NSN always shows, but it's basically pulling together all the different satellite positionings and mapping them into, well, all the different positioning technologies which are currently deployed, and mapping them into how they map into the FCC requirements. And we sort of think as, you know, wherever possible we use satellite positioning, but then there's the trilateration solutions for using terrestrial radio like OT, DOA and AFLT. We've got Wi-Fi, and they work in different environments better, and satellite obviously is great for remote areas, and then as you come through the different urban and then into indoors, there's different positioning technologies, and this is just showing the current positioning technologies. So if we look a little bit further, and the focus of this conference is indoor positioning, and these are just some ideas and, you know, of how we can extend the current systems to, you know, take account of information that may be available for indoor positioning. So if you, for example, from your mobile phone, if you could scan the barcode of a product on a shelf and it was known where that was in the Super Walmart, for example, you have a location. You could photograph an object in a museum or just anywhere, and if it was recognized by the system, you could have a location associated with it. In a warehouse, you have some very big warehouses and you just don't know where you are. There might be some kind of barcode or some kind of system to know where you are. And similar, in lots of office buildings, we have lots of office buildings where all the floors look the same, the buildings look the same, but you do have these identifiers around the office, such as a work cube identifier, and that means something to the system. If you could photograph that or somehow scan it in through your mobile device, you could identify a position from it. So the thing is that you know, the sort of legacy protocols didn't support carrying this additional information, whether it be photographs or barcodes or whatever. With these positioning, you know, with this kind of information, it's very related to local knowledge, to a building or whatever. And it also requires sort of extensions beyond the existing standardized protocols. So I'm going to look at a couple of enablers to support indoor positioning and new indoor positioning techniques. So I'm going to go over what Kirk earlier mentioned about discovered supple servers, and supple servers are part of the supple architecture, and they're the server side, and they rely on communication with a device. And the discovered supple servers are generally targeted, well, are intended to be targeted at specific vicinities or specific buildings, and they can be used to locate devices. Let me just have a breather. So they contain additional information about that vicinity where the device is. So, and procedures have been specified to discover the discovered supple servers and to get authorization from the sort of home supple server so that a device can use a discovered supple server. And a discovered server can be selected based on numerous criteria, but the obvious ones are the access type, the actual location, and the service type. Now, discovered supple servers were originally a supple 3.0 feature, which is the very latest version of supple, which is being standardized, but there's been an attempt, or a successful attempt, to port it back into a supple 2.0 context within the context of supple 2.1. And supple 2. And the reason for that is that there's been deployments of supple 2.0 at the moment, and people are concerned that supple 3.0 is just somewhat in the future, and putting this capability into supple 2 will speed up its introduction into networks. So, discovered supple servers, the opportunities. So obviously, these vicinity-based positioning, we can do this in a mall, a warehouse, an airport's terminal, university campus, or an office complex. That's the sort of buildings that we're targeting for discovered supple servers. And these supple servers contain specific local data to aid positioning in those locations. So local sensors, beacons, map information. And the discovered supple server can use standard or non-standard positioning technologies. Now the concept here is potentially commercialized by having maybe third-party supple server providers who are dedicated to indoor positioning for specific buildings. So, for example, the operator of a mall or the operator of a warehouse could provide some kind of supple server type information if they're big enough, or they could outsource it to a third party. A similar concept is the companies which deploy indoor coverage. There's companies, I think Andrews and there's several other companies which are out there who are putting in systems to improve the coverage in buildings and provide capacity in buildings. And maybe that kind of company could look into indoor positioning as well. One of the advantages of having a third party is that every different carrier wouldn't have to have their own supple servers or discovered supple servers and have to manage all that data and keep it up to date. The other thing is that a lot of indoor locations are actually, might contain confidential or even information, even in regards to the layout of the building or the contents of the building. But if you had a single third party with the appropriate security, they could go in and do the So the challenges we've discovered with supple servers are, this is a common theme, is the amount of data involved with these new positioning technologies. If you, for example, have to keep information on all the contents of a super Walmart and where all those products are in a big building, then just keeping that up to date is very challenging. There's also the standard security and subscriber privacy issues, and but that will just lead to the appropriate service level agreements if there are third parties involved in gathering this information. And there's also the issue that a particular discovered supple server could get overloaded in certain circumstances, and there just have to be some arrangement between the home carriers and the discovered supple server operator to manage the request throughput. Okay, so that was discovered supple servers. Now I was going to say a few words about the location positioning protocol, which is another enabler. So the advantage of the location positioning protocol is that it's been standardized by 3GPP in a fashion whereby it can be extended by other standards bodies, and the key thing about the LPP protocol is it runs directly between the device and a server. And what I'm showing here is a protocol stack from the 3GPP for LTE. But the key thing is that it doesn't rely on special protocols on every entity on the end-to-end link. It's a user plane type protocol, so it's between the device and the server. And it's been set up in a way that you can add extensions to it in a standardized fashion. And those extensions allow the device and the server to compare capabilities for different types of positioning methods, and then to pass information between each other. Now, the OMA has taken that 3GPP standard and developed extensions. And the advantage of this is that these extensions have been made for a range of positioning protocols, including those for legacy systems like GSM and UMTS, but it also allows wireless LAN and WiMAX and DSL and cable type information to be passed over the LPPE protocol to allow the maximum amount of information that could be used for positioning. So there are a few challenges with the LPPE implementations. One of the first ones is that there's so many choices and options, it's going to be challenging if the market's left to itself to just come up with compatible sets of positioning methods and support it within these protocols. So in many ways, it's going to have to be some carriers are going to have to define some profiles on this is what we expect in our network, both on our server and our devices. Otherwise, you'll end up with everything being incompatible. There'll be some devices which support, Wi-Fi positioning, and the server will only support beacons or something. There'll be some mix, some incompatible mixes. So the carriers do have a little bit of control, particularly the bigger ones. However, smaller carriers, they often get their devices and they can't control their devices. They're often on the open market, so there's still this issue of maybe the industry or some standards bodies need to define some very clear profiles of what's different layers of positioning capabilities. The other issue is just as more and more positioning technologies come available and are supported in these protocols, just more data to manage and just lots of more capabilities to support, and there's got to be some management of the complexity of the solutions. So to summarize, there's many new indoor positioning technologies coming and are here. Many require local information on the local buildings. And I presented two examples to help enable new indoor positioning technologies. There's the discovered supple servers and there's the LPP extensions. And both of these are part of the OMA location standards. And that's the end of my presentation.